Of all the rocky planets in our solar system, none is more mysterious than Venus. It's covered in a thick, hot atmosphere, so planetary scientists mainly rely on radar to peer through the clouds and study the surface below. And that surface is just weird, covered in shapes and patterns we don't see on any other planet. For decades, most researchers had assumed those patterns are from long in the past, and that for the most part, Venus is geologically inactive today. But thanks to new work published this week in the journal Nature Geoscience, there's now reason to think that might not be true. In many radar images of Venus, you can spot circular structures that seem to be made up of a bunch of rough, concentric lines. Geologists call these patterns coronas, and we know of more than 500 of them, with sizes ranging from a few dozen kilometers to 1,000 kilometers or more. Based on computer models of Venus, scientists suspect that they formed when pockets of molten rock pushed up from the planet's interior. On Earth, similar upwellings often create volcanoes as the magma squirts up through the boundaries between tectonic plates. Venus doesn't have tectonic plates. Its crust is one big plate that surrounds the entire planet. So instead, the magma just keeps pushing up until the crust buckles, cracking in the distinctive circular pattern of a corona. Until now, scientists had generally assumed that all this happened long in the past, when Venus's core was warmer and its crust was softer. But they actually had no way to know when this took place. That's where this new study comes in. The team behind it created new computer simulations to more accurately model the process of forming a corona on Venus. And they showed that the coronas form over the course of tens of millions of years in 4 distinct stages. Which is neat, but the surprise came when they compared their simulated coronas to the real ones observed on Venus's surface. Out of more than 100 real-life examples they looked at, the research team identified 37 that were still in one of the intermediate phases of formation, which in short means that geologic activity seems to still be happening on Venus, despite what many scientists have long believed. That's especially exciting news because NASA is in the early stages of designing their next solar system mission, and 2 of the 4 proposals they're considering would send a robotic explorer to our nearest neighbor. So if we do send another mission to Venus, there might be a lot more for it to explore than we even expected. For our second story, let's head farther out into the solar system. Between the planets of Jupiter and Neptune, there's a poorly understood collection of icy objects called centaurs. Astronomers have long suspected that centaurs represent the leftover building blocks of the solar system, just like asteroids and comets. But a paper published last week in the monthly notices of the Royal Astronomical Society suggests that some centaurs may have had an even more remarkable origin story. While they could still be the leftover raw materials of a solar system, it might not be our solar system. Instead, billions of years ago, they could have been stolen by the sun from another nearby star. The biggest clue is the centaur's weird orbits, which have long puzzled scientists. Rewind time a few million years, and it would seem that most centaurs should have collided with the sun or one of the planets long before they ever made it to today. So traditionally, scientists have believed that these objects don't stick around forever, and they're just constantly replenished by icy objects that wander in from the outer reaches of the solar system. But it's hard to be sure, because we don't actually know the orbits of most centaurs with a lot of precision. So astronomers can't just look back in time by taking their best guess at an object's orbit and rewinding the clock. And in the latest study, scientists suspected that at least some centaurs might have been around longer than we thought. To put their idea to the test, they focused on a group of 19 centaurs with highly tilted orbits that are fairly well known. Then, to account for the fact we don't know the trajectory of their orbits perfectly, the scientists ran up to 2 million simulations, each starting with a slightly different orbital path. In each iteration, they tracked the evolution of the centaur's orbit backward in time. Most versions of the simulation still resulted in centaurs that seem like they should have collided or been ejected in the past. But eventually, for each centaur in their sample, the researchers found hypothetical stable orbits lasting the age of the solar system. In other words, some of these objects really could have survived the solar system's whole 4.5 billion year lifetime. And there was something else special about them. When the researchers rewound the simulation to the time of solar system formation, the centaurs weren't located within the disk that the planets formed out of. Rather, they were oriented almost 90 degrees to it. That means that they almost certainly couldn't have formed alongside the planets, and must instead have come from somewhere else, like a nearby star. If they're right, that suggests that bits of material from other parts of the galaxy might be hiding right in plain sight. In the end, both these new studies show the power of a good computer simulation. They help us explore times and places that we can't see for ourselves and decide where to send our probes. Fortunately, from what we learned this week, we've got a lot of exciting options to consider. Thanks for watching this episode of SciShow Space News, and a special thanks to this month's President of Space, Faisal Saud, along with the rest of our patrons, for helping us bring you new episodes each week. If you'd like to help us keep creating new content, you can find more at patreon.com/SciShow.